All right, welcome to Center of Math's Advanced Knowledge Problem of the Week. For this week's problem, we're given a continuous real-valued function f going from the reals to the reals, and we define f of n equals 1 over n sum from n equals 0 to n minus 1 f of x plus k over n. Sum from k equals 0 to n minus 1. And we want to show f of n converges uniformly on every finite interval. F of n is a function of x. So first, note, given some x, as n goes to infinity, this is just a Riemann sum. So we know f is a continuous function, so clearly it's Riemann integrable. So the limit as n goes to infinity of 1 over n sum from k equals 0 to n minus 1 of f of x plus k over n. This is just summing a bunch of little rectangles. As n goes to infinity, this just approaches our integral x to x plus 1 f of y dy. So first we're going to manipulate a little bit. So we have our limit approaches this integral. I'm going to subtract off f of n, which is the sum. And we can rewrite this as a sum of lots of integrals. Sum from k equals 0 to n minus 1. Integral from x plus k over n to x plus k plus 1 over n. Integral f of y minus f of x plus k over n dy. So given some epsilon greater than 0, we're going to choose n large enough, so absolute value of f of y minus f of x plus k over n. Absolute value is less than epsilon. So since f is continuous, we clearly have some n such that this is true. And since our interval from x to x plus 1, it's contained in a compact interval on which our function is uniformly continuous. So we can pick some delta small enough or some n large enough so that this will be true for all the different k's. So for each one of these, as k varies from 0 to n plus 1, each one of these will be less than epsilon. The absolute value will be less than epsilon. And so now that we pick n large enough so that this is less than epsilon, we have so taking the absolute value of our sum and knowing that it's less than or equal to when we bring the absolute value inside, and then knowing that the absolute value of this is less than epsilon. So this whole thing is less than sum from k equals 0 to n minus 1 of the integral epsilon dy in each interval. And this integral is just epsilon over n, sum over n terms. So this is epsilon. And so we have the f minus f of n, absolute value is less than epsilon. For n sufficiently large enough, and yeah, xn value. And this shows that f of n, in fact, does uniformly converge to f. Thanks for watching. Please check out censormath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.